So, you flip a switch, the light turns on.
Right. Simple as that.
Exactly. And for decades, if you worked in IT or managed any kind of infrastructure, perfection was really just measured by that one very simple concept, just keeping lights on.
Yeah, the classic uptime metric, like, are the servers running? Is the network actually connected?
Right. If the dashboard is just full of green lights and the system hasn't crashed, everyone goes home happy. That is the whole era of measuring uptime. But welcome to your custom-tailored deep dive, because today we're going to explore why relying on that exact mindset in the age of artificial intelligence is just this massive, incredibly expensive trap.
Oh, totally. It's a huge trap.
Our mission today is to figure out how to successfully measure, and I guess more importantly, how to actually defend the true value of AI. We are basically hunting for the return on intelligence.
I love that phrase. And we actually have a really phenomenal source text to guide us through this today. We're looking at an excerpt from tech writer Aaron Rose, and it's called The Secret Life of Azure, the Adoption Curve.
Yeah, it's a great read.
It really is. And what makes this piece so compelling is that it uses a technical parable to explain some, honestly, very dense cloud architecture concepts.
It sets this amazing scene, too. Like, picture a grand Victorian library in London. We are talking dark mahogany wood, dusty archival books, stained glass.
Right, a place where slow, deliberate craftsmanship is, like, absolutely paramount.
Exactly. But inside this super historic space, operating entirely behind the scenes, we have these two very modern characters. There's Margaret, who's this highly seasoned, battle-tested senior software engineer, and Timothy, who is her rather anxious junior colleague.
And honestly, Timothy's anxiety is completely justified when you look at what he's facing.
100%.
Because the whole premise here is that tomorrow morning at 9 a.m., Timothy has to walk into a boardroom and sit down with the university dean and the chief financial officer.
Sounds terrifying.
Right. And his task is to justify the massive monthly cloud expenditure for the library's new AI research system. Specifically, they're utilizing Azure OpenAI provision throughput units.
Okay, wait. Which we should probably define for anyone who, hasn't had to sign a massive enterprise cloud contract recently. What does a provision throughput unit, or a PTU, actually mean for a business?
Yeah, so think of standard AI usage like a toll road. You pay this tiny little fee every single time a car drives through.
Okay, pretty standard.
Right, but a PTU is completely different. With a PTU, you are essentially leasing an entire private lane on that highway. It guarantees that your traffic will always move at top speed no matter how congested the rest of the network gets.
It's about guaranteeing performance.
Exactly, incredibly low latency, high performance. But the catch is that you pay a massive flat monthly fee for that private lane, and you pay it regardless of whether you have 10,000 cars driving on it or 0.
Wow, okay. So you are writing a massive check every 30 days. And, if you have ever had to justify a giant software bill to your own boss, you know exactly how Timothy is feeling right now.
Oh yeah, the pressure's on.
He's prepping for this boardroom showdown, and his entire defense strategy basically relies on that old-school IT mindset we talked about.
Right, the uptime defense.
Yeah. He pulls up his standard Azure Monitor dashboard, points to the availability line, and tells Margaret with just total pride that they have achieved a flat, perfect 99.95% uptime across all endpoints. 0 dropped requests in 30 days.
Which sounds great on paper.
Well, right, and as someone looking at this from the outside, I really have to play devil's advocate here. Why wouldn't a perfect system that literally never crashes instantly satisfy a CFO? Like, that sounds like a major engineering victory.
You'd think so, but Margaret dismantles that idea immediately. She tells him uptime is a lazy metric.
A lazy metric? Ouch.
Yeah, it's harsh but true. And if you put yourself in the shoes of a CFO, you can totally see why. When Timothy shows a graph proving 99.95% uptime, all he's actually communicating to the finance team is that the machine is successfully plugged into the wall and drawing power.
Oh, I see.
It proves the meter is running. It does absolutely nothing to prove that anyone in that Victorian library is actually getting smarter, doing their jobs faster, or that the AI is, solving any human problems whatsoever.
Right, so it's just a pulse check, basically a heartbeat monitor for a server rack.
Exactly that. So if Timothy walks into that boardroom tomorrow and slaps down a report of API gateway pings just to justify this massive budget for high-capability language model.
The CFO is going to cut his budget on the spot.
On the spot, because finance departments, they don't care about server health. They care about business value. They care about operational efficiency.
So that's the central conflict. To save the budget, and honestly probably Timothy's job, Margaret tells him they have to completely abandon their current strategy. She says they must stop measuring the infrastructure entirely and instead start measuring the human.
Which is such a massive paradigm shift.
Totally. And that brings us to how they actually pull this off, technically.
Right, so this is where the underlying engineering of the Azure platform really becomes the hero of the story. Margaret shows Timothy that she has already bypassed standard weblogging entirely.
And let's clarify that distinction, because I think it is super crucial. A standard weblog is passive. Like, if a user opens a web page, the server automatically writes down a little receipt that says, someone from this IP address requested this HTML file at 2 p.m.
Exactly, yeah.
It tells you traffic happened, but it is completely blind to the actual human experience occurring on that page.
And Margaret totally recognizes that blindness. So instead of relying on those default server logs, she utilizes Azure Application Insights.
Okay.
She goes directly into the application layer code, like the actual software these scholars are interacting with, and she manually instruments it.
Meaning she's writing custom code.
Yep. Right. She's writing code to act as these invisible tripwires. Every single time a scholar interacts with the AI, the application emits structured, custom events right back to Azure. She isn't tracking traffic at all. She's tracking what she calls the payload of human behavior.
The payload of human behavior. I mean, I love how that frames it.
It's so good.
So she pulls up this custom property schema she built, and she organizes it entirely around a user's journey. Let's trace what she is actually measuring here. Like, imagine a scholar sitting down at the terminal.
Okay.
Margaret's very first question is simply, do they even care to come back? That is why she fires an event called Session Start. She uses this to measure unique active users over time to basically calculate faculty retention.
Right, because retention is basically the bedrock of adoption. If they don't come back, nothing else matters.
Exactly.
But once that scholar is actually in the seat, she needs to know how heavily they are relying on the tool. That's where her next custom event, Query Submitted, comes into play. And she isn't just logging that a prompt was sent to the AI.
Right, it's way deeper than that.
Right. Yeah, the instrumentation actually measures the raw character length of the prompt and the specific historical persona the user targeted.
And that distinction matters immensely. Like, if the character length is 20 words, they are just using the AI like a basic search engine, right?
Yeah, just basic trivia.
But if the character length is, say, 2,000 words, it means a scholar is uploading these complex, multi-paragraph historical documents and demanding deep systemic analysis. It shows the AI is handling heavy cognitive lifting.
Which is exactly what they want.
Right. But then we reach the most critical part of the journey. The AI generates an answer. Did it actually help?
The million-dollar question.
Literally. So Margaret tracks this with an event called User Action. She attaches a telemetry sensor directly to specific interface buttons. So if the scholar clicks copy to clipboard or export citation, Azure registers a success.
And that specific event is just the absolute goldmine of this entire schema. That is the physical, undeniable proof of utility.
And on the flip side, she tracks failure just as rigorously. She built an event called Query Abandon. So if a user receives an output from the AI and then closes the terminal window within 5 seconds, the system logs a failure.
Oh, that's smart.
Yeah, it is the digital equivalent of a user throwing their hands up in disgust and just walking away.
Right, and the brilliance here is really how this arms Timothy for the boardroom. Like, Margaret anticipates the exact psychological dynamic of the CFO.
Which is what, exactly?
Well, when a company adopts a new AI tool, the immediate assumption from finance is that it's just an expensive novelty research project.
Oh, the classic shiny new toy syndrome.
Exactly. They assume employees are just playing with it, generating funny poems, or testing its limits, rather than doing, actual work.
And Margaret's custom telemetry just neutralizes that attack vector with hard mathematics.
Completely.
By explicitly capturing those user action events.
Right.
Like the actual physical clipping of export citation.
Yeah.
Timothy isn't just pointing to a vague graph of daily logins. He is bringing mathematical proof of tangible task completion.
Right. He can look the CFO in the eye and say, they aren't playing around. They are actively exporting citations to finish their research papers. And here is a ledger showing the exact thousands of times it happened this month.
Man, it is the difference between a gym owner bragging that the building's lights never flickered all month, which is measuring uptime, versus tracking if the gym members are actually lifting weights, breaking a sweat, and completing their workout routines.
That's a perfect analogy.
One proves the building has electricity, but the other proves the gym is actually fulfilling its core purpose.
Yep.
So proving the system is being used productively is this massive victory for Timothy. But it really only solves half of his problem for that 9 a.m. meeting. He still has to face the university dean.
And the dean presents a totally different challenge. Like,
Yeah.
the dean knows that the engineering team has been spending countless hours fine-tuning this base AI model, trying to make it better at parsing Victorian history. But the dean basically assumes all of that back-end engineering work is just academic tweaking, engineers tinkering in a sandbox with no real-world impact. Timothy has to prove that the AI is actually getting smarter and more effective over time.
Which is tough. Like, how do you mathematically prove that a machine is becoming a better historian?
It sounds impossible.
It does, but this is where Margaret introduces what has to be the most fascinating metric in the entire source material. She calls it the silent no.
Which honestly sounds like the title of a spy thriller.
It really does.
But it is actually this masterful piece of data science. So to reveal the silent no, Margaret opens up the log analytics query blade in Azure, and she writes a script using KQL, which stands for Custo Query Language.
Okay, let's pause there. For anyone who isn't deep in the weeds of cloud analytics, what makes KQL different from just a standard database search? Like, why does she need this specific tool?
Good question. So standard SQL databases are
Mhm.
really great for looking up static records, like finding a customer's billing address. But Azure Application Insights generates massive, rushing rivers of time series log data. We're talking millions of microevents happening every second. KQL is this specialized, incredibly fast query language designed specifically to analyze those massive streams of telemetry.
Oh, wow. So it handles the volume.
Yeah, and it allows you to find behavioral patterns across time. So Margaret uses KQL to isolate a specific sequence. She wants to find every single instance where a scholar submitted a prompt, received an answer, and then submitted a slightly rephrased version of that same prompt within 30 seconds.
So she's looking for the time delta between two specific actions.
Yes, she is literally measuring human frustration. When the base AI model first launched, scholars were just constantly fighting with it. The data shows they were rephrasing their prompts up to 4 times per single session.
4 times.
Yeah, because the AI's tone was too dense, or it hallucinated facts, or it just completely missed the nuance of the historical context. The scholars were essentially arguing with the machine.
That sounds exhausting. But then the engineering team implemented an automated feedback loop, right? They fine-tuned the model on the library's actual historical archives.
Exactly.
So Margaret executes her KQL script, and it generates this sharp, downward-sloping line graph. Since the fine-tuning, that 30-second rephrase rate has plummeted by an astonishing 62%. Scholars are just no longer typing follow-up questions.
It's a huge drop.
Yeah, and Margaret tells Timothy, this proves the scholars are finding the exact historical context they need on the very first turn. Now, I do have to pause and push back on this logic for a second.
Okay, let's hear.
How does a lack of a behavior like people physically not typing a follow-up question explicitly prove the AI gave a good answer? You might be wondering the same thing. Like, couldn't a massive drop in rephrases just mean the researchers got totally frustrated with the system's incompetence and just gave up entirely?
That is the ultimate trap of data analysis, honestly. If you look at any metric in a vacuum, you can project almost any narrative onto it. A sudden drop in user activity could absolutely signal catastrophic user fatigue. But this highlights the genius of Margaret's overall schema. She never designed these metrics to be viewed in isolation. You have to cross-reference the data points.
So you layer the telemetry to get the full picture.
Precisely. To address that exact pushback, Margaret connects the KQL script output with the custom events they set up earlier. We know the researchers aren't just giving up and walking away because we cross-reference the drop in rephrases with the query abandoned metric.
The 5-second rule thing.
Right. Are users closing the terminal within 5 seconds? No, that line actually remains flat. Then we look at the user action events, those clicks on copy to clipboard and export citation. Are those metrics crashing? No, they are actually steadily rising.
Okay, it is just incredibly satisfying to see this logic locked together like that. You take the downward sloping graph of the silent no, and you overlay it with the rising graph of explicit pass completion.
It's bulletproof.
It really is. It proves mathematically that the lack of rephrasing isn't user fatigue, it is first-turn success. The AI gave them a brilliant, highly contextual answer immediately, so they exported the citation and moved on with their day.
Yep, the model is undeniably faster, and the quality of the output is undeniably better. The engineering team's fine-tuning work is completely validated.
Which is awesome.
But solving the quality problem leads Timothy straight into a massive financial trap.
Right, the ultimate boardroom hurdle.
Yeah.
Because the highly capable, fine-tuned model they are currently running to achieve these amazing results costs significantly more per token than a basic standard fallback model.
Yeah, it's not cheap.
And we should probably clarify what a token actually is, because it is basically the fundamental currency of AI. An AI model doesn't read words the way humans do. It breaks text down into chunks.
Right.
So the single token is roughly 3/4 of an English word, or a couple of syllables. Every single time the AI reads a token in your prompt or generates a token in its answer, a fraction of a cent drops into the cloud provider's meter.
And those high-capability models, they charge a steep premium for every single one of those tokens.
So Timothy is suddenly terrified all over again, because he realizes the CFO is going to look at the raw cost per token of this premium tier, point to a standard model that is like half the price, and demand to know why the universities are paying premium rates.
Yeah, he's going to want answers.
How can Timothy possibly defend keeping the expensive model?
Well, he defends it with what Margaret calls token efficiency optimization.
Okay.
It is the absolute crux of the return on intelligence argument. She pulls up this composite workbook in Azure, and this workbook maps their Azure cost management billing data, the actual dollars and cents, right alongside the application insight session links.
Oh, she's mapping the time spent against the money spent.
Exactly. Let's look at the actual data she uncovers, because the correlation is just staggering. Under the old, cheaper model tier, a scholar would sit down to synthesize a complex historical timeline. On average, that research session took 11 minutes.
11 minutes for one timeline.
Right, because the model was cheap and it lacked context, so the scholar was constantly hitting that silent no. They were rephrasing, arguing with the AI, and generating massive useless outputs. Across all those back-and-forth prompts, a single task consumed roughly 12,000 tokens.
Okay, 12,000 tokens for the cheap model.
Now compare that to the high-capability, fine-tuned tier, the expensive one. Because the model understands the domain nuance immediately and achieves first-turn success, the average session duration drops from 11 minutes down to just 3 minutes.
Wow.
And because there is no back-and-forth arguing, the total consumption for the exact same task drops to only 4,500 tokens.
That is wild. This paradox is just absolutely brilliant. It is exactly like taking a taxi through a major city, you know?
Oh, I like this.
Right. Imagine you hire the cheap taxi. The per mile rate is incredibly low.
Mm-hmm.
But the driver doesn't really know the city, gets lost, drives you around in circles in heavy traffic for an hour, and by the time you finally arrive at your hotel, the meter has slowly ticked up to $50.
Right, death by 1,000 cuts.
Exactly. Now imagine you hire the luxury taxi. It charges literally double the rate per mile. But the driver is an absolute expert, knows a hidden shortcut, and gets you to your hotel in 10 minutes. The total fare is only $25. You're paying significantly more per mile, but you are paying half the price for the actual trip.
That is it exactly. And Margaret lays this exact reality out for Timothy. It is really her ultimate mic drop moment in the story. She tells him, yes, we pay a higher premium per token, but because the model is so intelligent, we consume 60% fewer tokens overall per research task.
Man. So by investing in the more capable model, they didn't just increase the quality of the academic research. They fundamentally eliminated the user friction, which inherently eliminated the token waste.
Which completely destroys the CFO's argument before he can even articulate it. Timothy isn't walking into that boardroom defending an expensive bloated system anymore. He is showcasing a highly tuned, ruthlessly efficient one.
The narrative actually notes how Timothy's entire posture changes in this moment.
Oh yeah, he's totally transformed.
He is no longer walking into a 9 a.m. firing squad, armed with just blind hope and a totally meaningless uptime graph. He has undeniable, multi-layered behavioral proof.
He watches the real-time telemetry on the dashboard. It is just blinking green as the night shift researchers log in across the ocean. The data is unequivocal at this point. They have an 84% faculty adoption rate. They have rock-solid week-over-week user retention.
Incredible.
And they have a direct, verifiable downward trend in total tokens consumed per successful search.
His anxiety just evaporates, replaced by total technical certainty. And Margaret gives him one final perfect piece of advice before the chapter ends. She says, the metrics don't blink. We aren't arguing about what the technology costs anymore. We are showing them what the technology saves.
The metrics don't blink. It is such a profound shift in perspective.
It really is. And it is a shift that applies far beyond a fictional Victorian library. Like, If you are an engineer trying to justify a complex cloud architecture budget, or a manager pitching a new software tool to your department, or honestly, even just a freelancer trying to analyze your own daily workflows.
The lesson is universal.
It is. You have to measure the human outcome, not just the technical input. If you are only tracking server uptime or basic login rates or raw page views, you are only measuring the machine. To prove real value, you have to find your own version of the silent no. You have to track the specific, granular behaviors that prove your tool is actively removing friction from a human being's life.
You basically have to map the human to measure the AI.
Exactly. But, as we wrap up this deep dive, there's a final thought that this whole parable sparked for me, something not explicitly mentioned in Aaron Rose's text, but it feels like the logical, honestly slightly unnerving next step of all this technology. Okay, what are you thinking? Well, Margaret and Timothy achieved their victory by using incredibly granular telemetry to perfectly map human behavior, right? They tracked micro frustrations, like a 30-second delay in typing. They instrumented exact task completions to optimize a financial budget.
Right. They turned human behavioral quirks into a math equation to optimize token spend.
So think about where this leads. What happens when organizations realize how powerful this telemetry is, and they start using these exact same granular principles to measure human-to-human interactions?
Oh, wow. That is a staggering implication.
Right. If we can now calculate the exact return on intelligence of a large language model down to the second and the token, how long until corporate dashboards try to calculate the exact minute-by-minute return on intelligence of our own human colleagues?
That's a little scary to think about.
How long until management software starts looking for the silent no in our own Zoom meetings, tracking how often we have to repeat ourselves, or how many micro-frustrations occur during a project sprint? Once the capability to perfectly map friction exists, people will want to point that dashboard at everything.
Yeah.
It really makes you wonder, if your daily workplace output was measured as rigorously as an AI token, would your metrics blink?
Definitely something to think about.
Something to mull over as you look at your own dashboards this week. Until next time, keep diving deep.